This meeting is being recorded.
Hello, my name is Yashwini Abhiramawali Jinaharan and I'm from section 1. So today I'll be doing my presentation for our bus station ticket system, which is implemented using the queue data structure. So the system follows the FIFO principle, which stands for first in, first out, meaning the first passenger added to the queue is the first one served. So these are my group members, and this is the group voter, this is me. Okay, okay, so I already gave a brief synopsis earlier, so I'll just be going to the code. Okay, so first we have the header files, which we include IO stream is used for input output. String allows us to store the passenger names and destinations, and IO and it is used to format the output while displaying the queue. And then we have the passenger structure. So this structure represents a single passenger, and it contains the passenger's name, the destination, and a pointer called next that links to the next passenger, and this allows us to form a linked list. So then we have the ticket queue class, and this queue is managed using a the ticket queue class. So inside the class, we have two pointers, which is for front and rear. Front pointer always points to the first passenger in the line, while the rear pointer points to the last passenger. So the constructor initializes the queue as empty by setting both the front and rear to null. So this indicates there are no passengers in the queue when the program starts. So part 1 is to enqueue the operation. So the enqueue function is used to add a passenger to the queue, and a new passenger node is created, and the user enters the passenger name and destination. If the queue is empty, both the front and rear will point to the new passenger, and if the queue already has a passenger, then the new passenger is added to the rear of the queue. So this maintains the first in, first out, so it will be added at the back. Yeah. So whatever that goes in first, it comes out first. Yeah. Okay. So then for part 2 of DQ operation, so the DQ function is used to serve a passenger. So the passenger at the front of the queue is removed first. If the queue is empty, a message is displayed. Otherwise, the front pointer moves to the next passenger and the served passenger is deleted from the memory. So this ensures the first passenger is added is the first one served. So part 3 is to display. So display queue function shows the passengers currently in the queue. It starts from the front and traverses linked list until the end. Each passenger name and destination are displayed in order. So if the queue is empty, a message is shown instead. And lastly is to check if the queue is empty. So this function checks whether the queue has any passengers. If the front pointer is null, the queue is empty. And since the queue is a linked list, there's no maximum size, unlike an array-based queue. It's either empty or not empty. So therefore, we only check whether the queue is empty or not. Yeah. So then we have the main function. So the main function provides a menu-driven interface. This one. And the user can choose to add a passenger, serve a passenger, display a queue, check the queue status, or exit the program. And this program continues running until the user chooses to exit, which is by entering 5. And then we have peer review. So for reflection, through this project, I gained a better understanding on how to use queue data structure using the FIFO principle. So implementing a queue using a linked list helped me understand pointers and the dynamic memory allocation in C++. And I also learned how abstract data structures can be applied in real-world scenarios, such as managing passengers in a ticket system. And overall, this project improved my problem-solving skills and strengthened my understanding of data structures. So in conclusion, this project demonstrates how a FIFO queue can be effectively implemented using linked list in C++. Thank you.